I've been alerted that black holes don't exist. Again, this isn't the first time I've been asked to assess an argument that seems to prove black holes aren't real. I want to talk about this because, in all fairness, it isn't a simple question. After all, the characteristic property of black holes is that you can't see them. How can you be sure that something exists which you can't see? Today's guest is Susie, my invisible friend. This newest claim comes from an astrophysicist and hasn't been published in a peer-reviewed journal, though the author has a preprint. The argument is in a nutshell that we're mistaken in thinking black holes exist because they take an infinite time to be created. But this is just the beginning. Hawking himself even claimed that black holes don't exist for a different reason. What? Yes, he liked to be provocative. So what's the truth? Do black holes exist, or are they physics' biggest delusion? First, we need to clarify what we even mean by a black hole. A black hole is a type of space-time geometry that's a solution to Einstein's field equations. Its defining property is the event horizon. That's a closed surface from within which nothing, not even light, can escape. Such a surface will generically form if matter becomes sufficiently compressed, for example, when a star collapses after a supernova. You can understand this in terms of escape velocity. To launch a rocket off the surface of a planet, you need a certain minimum initial velocity. This is the escape velocity. The higher the mass of the planet and the smaller the radius, the higher the velocity needs to be. Eventually, it exceeds the speed of light. That's when you have a black hole. In Einstein's theory, black holes have a singularity on the inside hidden behind the horizon. This is a place where the curvature of space-time becomes infinitely large and time ends. This singularity signals that there is something physically wrong here. This might be because we're missing a theory of quantum gravity, or maybe we're just misunderstanding black holes. If you were to drop this happy astronaut into a black hole and observe from the outside, you'd never see the observer drop in. You just see them move slower and slower, their colors shift to red and infrared, and eventually out of the visible range. This also means that if you could look at how a black hole forms from a distance, it would take an infinite amount of time. So doesn't this mean that black holes never form? No, because in Einstein's theory, time isn't one thing. There are many different times. The time that an observer outside of the black hole perceives is only one of them. The outside observer never sees the black hole form, but an observer who jumps into a black hole crosses the horizon in finite time and reaches the singularity at finite time. This is why time ends there. But my invisible friend says there isn't actually any such observer who jumps into the black hole, and even if there were, once they cross the horizon, they can't tell us what they saw. So what does it mean that the inside of a black hole is real? I think that's a fair argument, but it's a philosophical one. As a physicist, I have to admit that I don't really care. We have the mathematics for a black hole, and we use that on the outside of the black hole. If it describes observations, for me, that's good enough. More importantly, if one takes into account that black holes evaporate, as Stephen Hawking showed, then it's no longer true that black holes take an infinite amount of time to come into existence and that the inside is forever disconnected. It takes a very long time, 10 to the 100 years or so. But if black holes evaporate, then the inside slowly becomes visible and eventually the black hole entirely disappears. This is why I think it's reasonable to say that the inside of black holes is real, because we expect it to become visible eventually. What good is an invisible friend if you can't take photos with them? Okay, then what about the claim that black hole radiation prevents the horizon from forming in the first place? The idea here is that radiation starts being produced before the black hole horizon has been formed. The closer the collapsing star is to becoming a black hole, the hotter it gets. Matter evaporates by quantum effects but never forms the horizon. I'm afraid this argument is just mathematically wrong. The total loss of mass/energy from black hole radiation has been calculated thousands of times. For large astrophysical black holes, it's ridiculously tiny and can't prevent them from forming. By the way, this was the topic of my master's thesis. My professor wanted me to prove that black holes can't form because of Hawking radiation. He wasn't happy when I proved it didn't work, but math is math. What did Hawking mean when he said black holes don't exist? My interpretation is that he meant black holes aren't eternal. They disappear because they evaporate. In this case, mathematically, one doesn't have a true event horizon because such an event horizon would have to persist eternally. Instead, one has what's called an apparent horizon that looks for a potentially very long time, like an event horizon, but ultimately isn't. So yes, if you want to be ultra precise and only use the word black hole if you have an eternal event horizon, then technically what Hawking said is correct. But in practice, physicists use the word black hole also for cases in which the horizon is not eternal. Basically, if it walks like a black hole and quacks like a black hole, we call it a black hole. Why are astrophysicists so sure that black holes are real? Because they have a lot of indirect evidence. They can infer the radius and mass of the object by observing how stars orbit around them. They can observe how radiation heats up as it falls in. They can see how these objects bend light, and all of this fits black holes. Does this prove that the horizon is real and that black holes have an inside? No. But it does prove that the mathematics of black holes from Einstein's theory works just fine, and we haven't seen any deviations from it. The idea that the inside of black holes with the singularity doesn't exist is somewhat fringe but not total crackpot territory. Gerard 't Hooft, for example, has also argued that we're misinterpreting the math. He says that if something reaches the event horizon, it doesn't go inside the black hole. It comes out on the other side, but completely transformed. There are also a few people who think black holes are really solid objects with a hard surface, so-called gravastars. There are two problems with this idea. One is that if black holes had a hard surface rather than a horizon where things just fall through, you'd expect to see emissions when infalling stuff hits the surface. But we've never seen anything like this. Susie says she has evidence, but it's also invisible. The other issue with gravastars is that they'd need to exist at any density. I know this is somewhat confusing, but the larger a black hole, the lower the average density of matter if it were filled smoothly. This is because the radius of a black hole is the Schwarzschild radius, and that is proportional to the mass. So if you calculate the density, that's mass per radius cubed. Then that goes with the inverse of the mass squared, meaning that the larger the mass, the smaller the density. To get gravastars for all black holes, you need some spontaneous transition of matter to some other state at arbitrarily low density. Densities that we've tested in laboratories. For comparison, the density of a supermassive black hole like that in the Milky Way is comparable to the density of water. This is why I believe most physicists think this idea is theoretically a complete non-starter, if it quacks like a black hole. In summary, when physicists say that black holes exist, what they mean is that the mathematics of black holes describes our observations, no more and no less. I think it's fair to question whether the inside of a black hole is real, but I think this is a question for philosophy, not science. Many thanks to my co-host Susie, my invisible friend and one of the major constituents of dark matter. This discussion actually brings up the bigger question. What does reality mean? We can't see inside black holes. They might not exist forever because of Hawking radiation. They might not even have an inside mathematically.